LPWAN, Low Power Wide Area Network. Networks can use unlicensed frequency bands, meaning anyone can transmit for free without requesting authorization. To prevent any particular use from monopolizing this frequency band, equipment must not transmit more than 1% of the time in this band. So, if you transmit for 1 second, you must remain silent for 99 seconds. This constraint is called the duty cycle. Sigfox and LoRaWAN operate in the same frequency range and follow the same architecture. We will use the terminology from RFC 8376 to remain neutral. Network operators place radio gateways on the territory they want to cover. The radio gateways are connected to a central equipment, the network gateway, which will process messages received by the radio gateway. Each operator has its own infrastructure composed of radio gateways and network gateways. Radio gateways listen to a frequency band looking for frames transmitted by objects. Thus, if a Sigfox object transmits a frame, it will only be understood by Sigfox radio gateways and sent to its network gateway. LoRaWAN radio gateways will only see noise in the Sigfox transmission, and vice versa. Sigfox is a global operator and has only one network gateway, whereas LoRaWAN is a protocol that multiple operators can implement. When a LoRaWAN object transmits, all LoRaWAN radio gateways receive the message and send it to their respective network gateways. The network gateways will identify the object that made this transmission. If it is not recognized, the frame will be eliminated. Otherwise, it will be processed. The object owner must then configure the network gateway on which they registered the object to tell it what to do with the data. The network gateway will thus be able to send the data via an HTTP post, MQTT, topic, or WebSocket. The return path is more problematic because the radio gateway is also subject to duty cycles and can only transmit 1% of the time. So suppose we have 20 objects transmitting 1% of the time. If we require acknowledgments for each message, and the acts are the same size as the data to simplify, the radio gateway would need to transmit 20% of the time, which is impossible. LPWAN networks in unlicensed bands therefore require not acknowledging messages and are mainly dedicated to information collection usage, meaning sensors in the field that send back information. You won't control traffic lights with these technologies. 4G and 5G networks on licensed frequencies also offer LPWAN type services. To oversimplify, this corresponds to putting objects to sleep longer to save energy. Having their own band removes the duty cycle constraint. Operators can use all the capacity of the downlink between the object and the network. Finer control of transmission times can be done, leading to more interactivity and symmetrical communication.